All right, let's try to finish up with, thank you. Try to finish up with what we started. I'll pass your test back at the end of the class since Mia's finished now. So just remind me before we end class. Hopefully we'll be finished this before the end of class. All right, let's go right to example 4. Very similar, really, it's almost identical to what we did on example 3, but they throw in this other method, and this other method is a method that I used to do all the time. Remember I told you yesterday I used to do this one method till I was teaching, and then Mr. Jackson, was telling these kids how to do it, and I was like, wow, why did nobody ever tell me this before? Yeah, because I just want to show you the difference, okay? I'm not going to go through the whole entire routine, but here's what you're going to do, okay? You're going to factor. Now, sometimes this method could be, depending on how well you guess, this might be super quick and easy, all right? But sometimes you're going to try over and over and over and over again, all these different guesses, all right? And I call this the guess and check method, all right? You're just going to guess. Which numbers? It's an educated guess, okay? You're not just going to pick any random numbers, but it's an educated guess. But sometimes you might have to try 4, 5, 6, 7 different things before you get one that works. And then sometimes you might guess it right off the bat. So it all depends, right? Which was a better method. I like the other method that I taught you yesterday. It might be just a tad longer, but it's the same method every single time, and it always works, I think. I'll say it always works. It may not, but it normally does. So here we go. This is what we're going to factor. So 3x squared plus 19x minus 14. Now, when the a, remember in the quadratic formula, or not formula, but equation? It's not even equation. We're going to be doing that tomorrow, I think. But anyway, in this quadratic polynomial, let's call it that. That first one right here, that's an a, correct? Remember ax squared plus bx plus c? If that is not a 1, if it's anything different than a 1, it makes this thing a little bit tougher. So you could sit here and just guess a bunch of numbers. But you got to be, again, like I said earlier, you can't just pick random numbers. So this first one and this first one have to multiply to be what? Not 19. Multiply. This times this has to multiply to be what? Think of doing the FOIL method. Say it, Angela. 3x squared, right. So this could be a what? 3x, and this could be a what? X, okay? So those are your options there. Agreed? Okay. Yeah. And then you got to figure out some numbers that could be this. Okay, so what times what equals negative 14? Okay, 7 and 2, right? So 1 and 14. So you got 4 options there, don't you? And you got 2 options here. I could have made this one x and that one 3x, right? And that would make a difference on when you add these together and try to get that middle number. So let's just say we wanted to go 7 and negative 2. Now, the first and the last ones work, don't they? But it's the outside and inside that have to do what? They have to add up to be 19, all right? So let's just see. Again, I just guessed. Again, when I say guess, I'll put it in air quotes because I knew this has to be a 3x and an x. I know that, or I should say this. I know that this one times this one has to be 3x squared, and I know that this one and this one have to multiply to be negative 14. So I wouldn't pick like 3 and 5 here, would I? Because there's no way I can get a 14 out of that. Make sense? Okay, so what are my choices? I could go 2 and 7 or 1 and 14. I could go negative 2, positive 7, or I could go what? Negative 7, positive 2, right? That's 4 options, right? 2 options right there. And then I could go 14 and 1. I could go positive, negative, negative, positive. So right there, there's 4 different options just on getting 14, right? And then you got 2 options with the 3x. Do you see how if you don't pick the right numbers early, it could be a long process? Let's see if this works. Outside and inside. What's the outside? If I multiply those together, what do I get? The two outside ones. Negative 6x. Okay, so I got negative 6x plus 7x. Is that 19x? No. So I got to try something else. Right? What do you want to change? The 2 and the 7? So put the 2 here. Is that what you said? And the 7 here? Okay. Let's go. And switch. Okay, so
minus 2 over there.
So minus 2 right here? Okay. Are you just picking that because it works? What's that? So what'd you say? Minus and plus? And 2 and 7? Okay. So let's see if that works. Again, you know the first and the last work, right? Every time they should work. It's the outside and inside. So what do I get? I got positive 21 and negative 2x. Oh, positive 21 minus 2x is what? 19. Now you got lucky, all right, and got it in the second shot. Agreed? So that's a pretty good method, all right, if you only got to try and just mess up once and get it on the second try. But you could see, couldn't you, where if you don't try the right numbers early enough, you could keep trying until you get it right. Is that really a great method? Probably not. All right, but it's a method that I used all the time. I used to teach all the time. All right, just guess and check. Just keep putting numbers in here until it works. I mean, I remember some problems. I mean, I would go way down the paper until I finally picked the 2 that work. But somebody else might have got lucky and just picked the correct ones in there and got it right the first time. All right, so it's hard to tell. So let's do it the way that I taught you. How did I teach you? Yeah, take that 3 times negative 14 and get a number. And you get, what's that? 42? Negative 42? Yep. All right, now what you have to do is this. You got to think of 2 numbers that multiply to be negative 42, and those same 2 numbers add up to be what? 19. Okay? So, I mean, it takes a little bit of thought. It takes knowing some multiplication tables. So what do we think? What times what is 42? Well, we got 42 times 1, right? We got 21 times 2. We got 6 times 7, right? And you could always go the other way too, right? Change the negative and positive. So you got a lot of options. But what's going to give you a 19 out of those numbers? The 21 and 2, right? Okay, and it's going to be a positive 21 and a what? And a negative 2. Would you agree? That equals negative 42 when you multiply them. And when you add them up, 21 plus negative 2 equals what? 19. Okay? So you just go through the factors of 42 in your head. Like 6 and 7. Is there any way you're going to get a 19 out of a 6 and a 7? No, there's no way. All right, what about 41 or 42 and 1? Because sometimes that is an option, using the number and 1. Okay? No, there's no way you're going to get a 19 out of that. But then you're like 21 and 2, oh yeah, I can get a 19 out of that, right? So that's how you do it. Does that make sense? So that's what's going through our mind. Again, knowing your multiplication tables is a huge advantage, all right? So now what do we do with that? What we're going to do is we're going to rewrite 19x as 21x and negative 2x. Do you see that? That's the whole purpose of finding these 2 numbers. These 2 numbers are really important because we're going to rewrite that 19x. So watch, I'm going to get 3x squared plus what? 21x. I'm going to do this. Since it's a negative, I'm going to go plus a negative. Yeah, I'm trying to think of the best way to do this. After a while, you kind of get used to this. But you could put a negative 1 there and then what? 2x. Would you agree? That's 21x, that's negative 2x, that's 19x. Yeah, it's the same thing. It's the same thing as this. I just rewrote it as 21x minus 2x. And then a minus 14. Now, why did we do that? We did that so that I could group these. This is called factor by grouping. This is something like if you were taking an Algebra 1 class, you'd probably do a whole entire lesson just on factoring by grouping, all right? But again, it's Algebra 2. They're making assumptions that you kind of already knew how to do this in Algebra 1, all right? But, you know, I hate to make any assumptions. All right, so I'm going to group it like this. So just look at this one parentheses right there. What do I have in common? I got a 3 and an x. So let's factor out a 3x just from this group, okay, from that first set of parentheses. What do I get? X plus 7, okay? Everybody with me? Whoops. All right. Again, I'm trying to think of the best way to do this. Let's go plus. What's in common with both of these? A 2, right? A negative 2. So I factor out a negative 2 from both of these. If I factor out a negative 2 from negative 2x, what am I left with? X. If I factor out a negative 2 from this, remember when I say factor it out, it means I'm dividing it. It's negative 14 divided by negative 2. What is that? It's plus 7. Check this out. So if this works correctly, then I'm going to have 2 of these parentheses being the same exact number. And we're almost done. Okay, one more step and we're finished. What can I do? I got greatest common factor, don't I? All right, so I've got an x plus 7 is in common with both of these. And what do I have left over? If I factor an x plus 7 from there, I got a 3x. If I take a x plus 7 out of this, what am I left with? A minus 2, and then there it is. Does that work? Yeah, let's do it. The first one's, that's 3x squared. The last one's negative 14. And then the outside and the inside, right, that's negative 2x plus 21x is 19x. It works, doesn't it? Okay. Now, that might be a couple extra steps than guessing and checking, all right? You might have guessed 3-4 times, and that might be the same amount of work as it is to do this. But this one, I think, is a little more direct. It kind of makes sense a little bit more instead of just guessing a whole bunch of numbers. I mean, you had to guess a little bit here, but this truly wasn't guessing, was it? It's just knowing your multiplication tables. So it's not truly guessing, but the other one kind of was, all right, in part. Yes. All right. Now, we're ready to do some new stuff. That was kind of rehash of yesterday, really, to tell you the truth. So here's some new stuff. I'm going to give you 2 different things to look at here. Yeah, 2 and a little bit. First thing, I think I mentioned this yesterday, but we're going to really get into it today. It's called the difference of 2 squares. Actually, no, I didn't talk about this yesterday. I think I mentioned something else. What does that mean, the difference of 2 squares? I like to know the name of this because it fits with what we're trying to do here. So if I was to factor something that looked like this, a squared minus b squared. Actually, tell you the truth, let's just show it to you. Equals, I'll just show you what it is. It's a plus b times a minus b. If you didn't believe me, go the other way. Foil it, all right? A times a squared. Let's do that. See, that's oh, come on. Keep pushing that button on this pen. That's a squared. What's the outside? Negative what? ab. What's the inside? Plus ab. What's the last? Minus b squared. Do you see it? They add up to 0, and so it is a squared minus b squared. Everybody see that? All right. So this is really important. So when you see something like this, when you see something squared minus, remember this is called the difference of 2 squares. By the way, there is no sum of 2 squares. Later on, I don't know when, I haven't taught this book before, so I'm not sure when they do this or if they even do this. It might be not, they might not do it until the next thing. I don't know. My guess is they'd probably do this in Algebra 2. But there is a sum and difference of 2 cubes. We're not doing that yet. It might be in this chapter. I don't even know. I haven't even gone that far. But you do have a difference of two squares. There is no sum of two squares. When's difference of two cubes and sum of two cubes? Is that in there? Is it a lesson, or is it just a problem in this? Okay, what lesson is it? That's my point. What section? 5 who? 5.2? We're on 5.2. I don't think that was... You might be looking at something different. You might be looking at something different. Okay, anyway, let's do this. There is a difference of two squares. So let's do a problem. What? They don't even give you an example. Example 5, they went right to a perfect square. They didn't even do difference. I'll make up an example. These are easy to make up, okay? So something squared. So like if I had 25x squared minus 36y squared. This is a difference of two squares. How do you know? Well, you got a difference. That's the first thing you look at. Everybody watching up here? Seems like people are not paying attention. Got heads on the desk. Okay, tap her, wake her up. All right, so I've got a difference, and look, are both of these things being squared? Is something being squared to give you 25? Yeah, 5 is, right? 5 squared. Is something being squared to give you x squared? X is, x squared. What about this? Yep, 6 squared, y squared. You follow me? So these are probably except for maybe greatest common factor, these are probably the easiest. It might be even easier than that, depending on the problem. The easiest factoring that you're going to do. So here's what I do. These are both exactly the same, except for what? One's positive and one's negative. So watch what I'm going to do. I'm going to put my two parentheses. I'm going to make one positive. I'm going to make one negative before I stick anything inside of there. That's what I do. Okay, when I recognize that it's a difference of two squares, that's what I do. Okay, now what goes here? This times this has to be 25x squared. So what is it going to be? 5x. And that's going to be the same exact thing. See how the A and the A is right there? It means they're the same exact thing. And then what's being squared to give you 36y squared? 6y and 6y. One's plus, one's minus. Okay, so they're not the exact same thing, but they're pretty close. That's how you factor a difference of two squares. Well, it's one of the easier versions of this. What if I gave you something like this? What if I gave you 4x squared y to the 4th minus 81 x to the 6th y to the 10th? You asked if that was all. Okay, so what I'm going to do is this. Actually, I shouldn't have put the equals there. What I want to do is find out what is being squared here. What's being squared to give you a 4? A 2. What's that? Right there? That? You didn't write that down? Okay. What's being squared to give you a 4? 2. What's being squared to give you an x squared? An x. What's being squared to give you y to the 4th? Y to the 2nd. So all that is being what? Squared. All I'm doing is just rewriting it. I'll put it in this form in a second. All right? You might be able to go directly from this to this. All right? But I'm just trying to make it easier for you. Minus, what's being squared to gives you 81? Right here. X to the 3rd, right? X to the 3rd squared is x to the 6th. Agreed? What's being squared here? Y to the 5th. All that is being what? Squared. So this really fits this formula really nice, doesn't it? This would be like the A, and this would be the B. So how do you write this thing then? You put your two parentheses, and you go what? 2xy squared. I should have done this, plus or minus. And then 2xy squared here. Then you do the B part of it. Would be what? 9x cubed y to the 5th. I didn't give myself enough room. 9x cubed y to the 5th. And that would be factored. Okay? So that's a difference of two squares. They don't give you an example, at least in the book that I saw. At least I didn't write it down. But that would be the example. I just made that up. All right. Now, here's another one. This is called the perfect square trinomial. Perfect square. No. Perfect square trinomial. Trinomial. Okay. So here's what it means to be a perfect square. Now, you could have a plus or a minus with this. This is different than what we did before. Do you see the difference? This right here, what are you squaring? The A, then you got a minus, and then what are you squaring? The B. Is that what's going on here? This is not A squared plus B squared, is it? There's no distributive property with exponents, okay? So a lot of people think you can do that, but you can't. So this is different. You're taking that whole A plus B and then you're squaring that, all right? There is a way to get an answer for this, and it's this. It's A squared plus 2AB plus B squared. Now, I could have done distributive property. Let's do that. I should have done that right off the bat instead of writing this out. Just remember that. I'll come back to it. If I was to actually square this thing, what would I get? How would I do that? How would I do the math? I would go A plus B times what? A plus B. All right? Everybody with me? I'm just coming up with our little, it's not really a formula, but our little thing. I don't know. So what do we got? A squared outside is plus what? AB. Inside is AB plus last is B squared. So I've got A squared. Let's add these up. What's 1AB plus 1AB? 2AB. See where that came from? Plus B squared. So this is a perfect square. So when you have something like this, that's what you're going to end up with. What we're concerned about is this. Now, if I gave you this, you should be able to put the two parentheses next to each other, FOIL it, no big deal. But what are we doing now, though? We're not just multiplying stuff. We did that in the first section. What are we doing? We're factoring. So what you have to do is look at this, recognize that it's a perfect square, and then it should be really easy to factor. Okay? This is the key right here. This is the key to looking at these problems. Now, the A minus B is the same exact thing, except for just one sign. Again, I'm not going to take the time to go through and FOIL that. I'll just show you what it is. It's A squared minus 2AB, and this is still going to be plus B squared. You understand why it's still a plus? Because I'm going to have a negative b times a negative b, which is positive b squared. Okay? So here's the two things you're going to look for. Oops. All right, so that's your perfect square trinomial. You're looking for this. You're looking for something in that form, and then once you realize that it's in that form, then it's super easy to factor. All right, let's do an example. So, factor. X squared. You could do this kind of like the old-fashioned factoring when you have a trinomial, but it works with this as well. Take a look at this. Is something being squared to give you that? Yes. Is something being squared to give you that? That's the first alarm bell that goes off. Okay, when you're looking at it, you're like, oh yeah, something's being squared here, something's being squared here. Like if I had a 17, is there anything that's being squared to give you 17? Any whole number? No, there's no whole number or integer that's going to give you a 17. But at 25, you're like, yeah. Now, here's the key. What is the A here? It's a 1, all right? And what is the B? It's a 5. Agreed? All right, so and if you look at here, this is where I'm looking, right there. So does this work? If I go 1 times 5 and then double it, is it 10? Yes, it is. So that's what you need to look for. Is everybody awake? A few of you are nodding off. You got to watch. Okay, this is super helpful. So I take this. I should say this. The number that's out in front, we'll just call it the A, okay? It's actually the square root of it. But because the square root of 1 is 1 anyway, right? And then the square root of 25 is 5. So if I take the square root of both of those, add them up, and then double it, is it your middle one? If it is, then this is a perfect square. So I'm like, oh, okay. I look at this. That's a perfect square. This is a plus, so that's a plus. What's being squared to give you that? What's being squared to give you that? You're done. It's as easy as that. Let's do another one. Just push this up just a tad. What about this? 4y squared minus 28y plus 49. All right, so it says to factor it. What's the first thing we look for? Look for the first term and the last term. Okay, is something being squared to give you that first term and that last term? Is something being squared to give you 4y squared? Yeah, 2y, right? Is something being squared to give you 49? Yeah, 7. So that right there tells me, oh, this has a possibility of being a perfect square. How do I know for sure if it's a perfect square? I take that 2y, right? Remember, the square root of this is 2y. That's kind of in my head right there. You got it? What's the square root of that? 7. If I multiply those together, I get what? 14. But then I do what? If I double it, and it's this middle number right here, then it's a perfect square. Does it work? Absolutely, okay? Because 2y and 7 is 14y. Double it, it's 28y. All right? So this is a perfect square. So all I got to do is just put the little squared thing. What sign's going to go in the middle? Minus, because that minus right there. Okay, so you put a minus here. Now, what goes here? Whatever's being squared. What's being squared to give you 4y squared? 2y. What's being squared to give you 49? Now it's factored. Okay? It's easy to factor it. You just have to look at it and realize that, oh yeah, this is one of my perfect squares. All right? Does that make any sense?
Yes.
All right. They only give you those two as examples, but you'll have some more to practice in the homework. Okay? They give you one more example. It's a little different, but kind of the same. They say factor, this is the last one, factor 8a squared minus 32. Well, it doesn't look like a perfect square, does it? Because a perfect square would have 3 terms in it. Okay? It could be a what? Difference of, I say it could be a difference of 2 squares. Because I got a difference, don't I? And I do have a squared here. But is there something that's squared to give you 8? No. Is there something squared to give you 32? No. So what do? Well, let's go back to the very, very first method we learned how to factor. What was that? Greatest common factor. Always, always, always look to see if there's a greatest common factor. All right? Is there something in common with both of these? Yeah, what is it? It's 8. That's right. So always look for that. If I factor out an 8 from this, I'm left with a squared. If I factor out an 8 from this, I'm left with a 4. Am I done? No, I got to go further. A lot of books will say this. Instead of just factor, they'll say factor completely. Okay? That means factor it until you can't factor anymore. So if they just tell you to factor it, that's what they mean. Okay? Even if they don't say completely. They mean factor it as much as you possibly can. Right? Because this thing right here, in that parentheses, I can factor that. And what is it? It's one of my special factoring things. What is it? We just learned it today. It's a that of this. Difference of 2 squares. That's right. So this is a difference of 2 squares. So I'm going to keep the 8 there. How do I factor a difference of 2 squares? I put 2 parentheses, I put 1 is plus, 1 is minus. What's being squared to give you a squared? So I put that here and here. What's being squared to give you 4? Put a 2 here and a 2 here. Now, can I factor anything else? Nope, that's it. It's factored completely, and that's the only acceptable answer right there. I shouldn't say the only one. You could have put the a minus 2 before the a plus 2. That could be different, I guess, but that's good enough. That's it. What do you think? Did you guys do this in Algebra 1? Do you remember difference of 2 squares, or you do any of this? Even greatest common factor? Okay, you did that. Okay. All right. But this perfect square thing, it doesn't come up all the time, but it's something that's really nice to be able to look at and say, oh yeah, that's one of those perfect squares. Once you realize that, it's super easy to factor, okay? You just have to realize what it is. And how do you do that? You take the square root of this, the square root of that, multiply them, double it. Is it your middle number? If it is, it's a perfect square. If it's not, you got to figure out another way to do it. I didn't. It's in 2 days. I gave you half of it yesterday. Okay? So I split it up into 2 days. Right? Here's a difference of 2 squares. Here's a difference of 2 squares. Okay? That's one of your like special. That's what I call it. Okay? Kind of what your special factorings. Like this right here, to me, is kind of like a more normal factoring. I don't know if other teachers say that or not. But I think this is like a normal, regular factoring. And I think of difference of 2 squares as being kind of specialized. And I think of this perfect square as being kind of specialized. All right? In chapter 6? It's not till chapter 6. What are we on now? 5? Oh, so it is the next chapter. I think that's what I said too, wasn't it? Yeah, I figured it would be pretty soon. It was either in this one or the next one. But that's different. We won't worry about that until we get to it. It's a little bit longer, but if you remember one little thing, it's not that bad. Take a look at your homework. Do you have any?
Yes. Can we do some homework?
All right.
Can we get our test call?
Yeah, we got 15 minutes. So 10 minutes on the homework, okay? So give me some homework problems. Actually, just tell me which ones. I got the book here. Oh, I thought you... Man, you went all the way there? All right. Who asked? Angela? Who did? Okay, Zanai, read it off to me. I got it here, but it might be easier if you just read it off. A to the 5th, b squared, what else? Plus 2a to the 4th. Keep going. It might be easier if I read it off. I thought you were going to just b to the 3rd, a to the 3rd, b to the 4th. Okay. I'm not going to write it, but it's every one of these says factor, so you know what to do. So, does this look like a difference of 2 squares? Does it look like a perfect square? Does it look like one of those trinomial thingies? It is a trinomial, but does it look like the quadratic? Does it look like a quadratic? Doesn't look like any of those. So what would you do? What would you try to do? What was the first way we learned how to greatest common factor? Is there anything in common? Yeah, look at the a's. I got a to the 5th, a to the 4th, a to the 3rd. What's in common with all three of those? A to the 3rd's in common with all three of them. And then a b squared, b cubed, b to the 4th, b squared is in common. And so I just factor that out. Okay? So what do I get? A to the 5th. This is really division, isn't it? I mean, I'll say this phrase all the time, factor it out. I've heard some teachers don't like that. But that's what I say, all right? So if I factor this out from this or divide, a to the 5th over a cubed is what? A squared. B squared over b squared is just 1. Plus, remember, there's a 1 in front of there, right? So 2 divided by 1, that's just a 2. A to the 4th divided by a cubed is a. B cubed over b squared is b. Plus, what's this? A cubed over a cubed, it's 1. B to the 4th over b squared is b squared. Now, how can we make that look a little prettier? This looks like what? Well, what's the first word? Perfect square. This is a perfect square, isn't it? All right? I mean, it's exactly the way the perfect square was written. Okay? So I could... Do they write it like that in here? I thought I saw it. Yeah, they do. All right, so you realize that that's a perfect square, so I could factor that. So I still got to keep this stuff, because this is still being multiplied by that, right? And now I can do this. What's my sign, first of all? It's plus. You always look there, okay? That one's always going to be plus. Okay, this one could change, all right? But it's positive, so we put positive here. So what do we have? Just take the square root of this, which is a. Take the square root of this, or what's being squared, right? I've been asking that question a lot. B, and then there you go. That's factored. So some of them take 2 steps. Sometimes you might have 3 steps, okay? And the higher up you go in this, you might have more than that, all right? But in this case, it's only 2 steps. No, because it's not completely factored. I mean, technically it is factored, but remember what I said. When they say factor, they mean factor what? Completely. Okay, again, some books are really particular about that, and they put the word completely in there. I don't think this one... Oh, it does. Look at it. It does say factor completely. Yep. So, yeah, absolutely. If you just wrote this, I'd mark it wrong. Okay? This is correct. You got to practice this. Listen, I'm telling you. Everybody listening?
Listening.
You have got to practice this. Okay? In fact, I just gave you odds, didn't I? I should have given you all of them. But I didn't. But it's so important for you to practice this. Okay? Don't look at this homework as being a punishment or just something a teacher does. I'm giving you the homeworks. Why do I give you these homeworks to do? I mean, look, I got to grade them. Not that it takes that long to grade, but still, it'd be a lot easier for me if I didn't give you any homework, to tell you the truth. But that wouldn't help you, all right? It's to help you. That's what it's for, all right? If you don't do this stuff on your own, look at it on your own without anybody whispering over your shoulder and telling you what to do, you're not going to be able to do these. You've got to try these on your own. Everybody got that? All right. I think I'm preaching to the choir. My morning classes, I have these talks all the time. You guys are usually pretty good about doing your homework, so I don't have to preach to you guys too much. All right, but this especially is super important that you do problems over and over and over again, because that's the only way that you're going to get good at this. All right, use the rest of the time. We got like 7-8 minutes left. Okay, use the time to do a couple of these. All right, try it. You got your notebooks open. All right, just get a piece of paper out, put problems down, and there you go. All right. So what was the assignment, by the way? 1 to 37 odd. So let me write that down. So we're just going to call it section 5.2. We're not going to go A or B. And it's, what was it again? 1 to what? 37. All?
Why would you say that?
Okay, you're just doing the odds, which means after you do an odd problem, what should you do?
Check the answer in the back
You
of the
should
book.
check the answer to see if you did it right. Okay, and then go on to the next one. If you got it right, go to the next one. What if you got it wrong? What should you do? I'm not saying what you actually do. You should try it again. But don't sit there and try it 4 or 5 times. That would take forever, all right? Try it at least one more time until you get it. Well, at least one more time. Okay, enough of that.